Great. Once again, TIG, a California tram manufacturer. We specialize in designing transit systems and providing the manufacture of self-powered trams. When I say self-powered trams, I am referring to trams that carry all power for a full day of service on board each car. So that means there is no wayside power requirement, no overhead wires, no charging at stations, no wayside power of any kind. The cars come out of the depot every morning with enough power to carry passengers for up to 20 hours of service each day. We do that with a set of battery hydrogen hybrid traction power systems. And we design and build cars of various sizes. We have a 200-passenger articulated modern car, a 100-passenger single-body modern car, and various size up to 80-passenger heritage-style cars, which we operate around the world. Now, all of our cars, no matter what the architecture of the coachwork is, utilize our battery hydrogen electric propulsion system. The technology is exactly the same no matter what the car looks like. These are our international transportation design, build, operate, maintain contracts around the world currently. And we are involved around the world, currently proposing in the country of Turkey. Just came back from our project in Doha, where we are preparing to assist in the incredible World Cup activities that are going on there. TIG is a unique turnkey street railway system design, construction, and vehicle fabrication firm. We provide all of these services, or any one of these services, to our clients depending on what their needs are. We provide everything from feasibility study to operations and maintenance and everything in between through our partnerships with international companies in all of these fields. Our mission is to reduce streetcar infrastructure impacts and costs by eliminating the need for continuous off-board electrification systems, and to produce and deliver carbon-neutral public transportation systems to help meet greenhouse gas mitigation goals around the world. We've spent the last 20 years redesigning every system and subsystem in the streetcar to operate at minimum energy consumption while maximizing power and safety as required in transit vehicle systems. So once again, our streetcars require no overhead catenary, no design and build of those systems, or any other type of external power supply, operating entirely on internal battery hybrid systems. Over the course of our short existence, we were formed in 2005. We have achieved several groundbreaking world's first milestones. Our first battery-powered streetcar of the modern era in the year 2000. First solar-powered wireless streetcar system in the U.S. in 2011. First use of hydrogen fuel cell in a passenger rail vehicle in 2013. Installation of the first hydrogen fueling station in the Emirate of Dubai. First fully self-powered streetcar tram capable of 20 hours of passenger service without recharging. And the first public operation of a hydrogen electric passenger rail vehicle in North America in 2021. In 2020, in the International Light Rail Awards, we won Manufacturer of the Year and several other awards. Now, the advantages of self-powered streetcars over catenary-powered systems are several. Wayside power systems, including passenger station charging systems, represent on average 30 to 50% of the cost of streetcar infrastructure, and in some cases much more. Wayside power systems represent a single point failure mode. If the wayside power system fails, all the vehicles are immobilized. This is not so with individually powered trams. Wayside power systems have a greater impact on the built environment. Eliminating wayside power represents the removal of the two major impediments to implementation of new streetcar lines, and that being the high cost of the infrastructure, both short-term and long-term, and the resistance of the public to visible power poles, lines, and substations. So I just returned from Qatar, where we are supporting our fleet of cars in the downtown Musharraf Doha development. This is our car there, dressed up for the World Cup and Qatar Airways advertising. And we are operating there a fleet of TIG-M MRV 3AC single body modern streetcars with a passenger capacity of 100. This is another car in the fleet. Here is a view of three cars, three 100-passenger cars that are operating in a platoon under the control of one driver. So this represents 300 passengers as a platoon. Now, these cars can be separated at any time, but driven as separate passenger. Each of our cars has many advanced systems, including virtual tram detection, next tram arrival, onboard CCTV, IP camera broadcasting, whereby we can diagnose the systems, the performance of the cars remotely from our maintenance facility here in California and from the local depot, wherever they may be around the world, through an onboard Cisco wireless access point. Now we have our TIG-M MRV4 articulated modern streetcar, which has a passenger capacity of 200 based on the same technology. And then we'll talk a little bit about virtual coupler, which I've already mentioned. We have the ability to join cars wireless through wireless technology. This allows us to provide scalable tram size through non-mechanical vehicle coupling at the push of a button. Trams can be sized to reflect demands during peak and off-peak hours. This reduces excessive driver costs and eliminates the deadheading of empty seats. A lot of times I see around the world very large capacity trams operating at very low ridership during off-peak hours, deadheading 80 and above % of their seats. In this case, we can separate the cars and during off-peak hours operate smaller cars, thereby reducing overall maintenance costs and driver costs. It looks like this in operation. Three 100-passenger cars can come together at a station from different alignments or different headways and drive away at the control of a single driver with a 300-passenger consist. Just so with our 200-passenger car, two cars can come together. One of the drivers is retired, and the consist drives away under the control of one driver as a 400-passenger consist. Now, because the vehicles are self-powered, the track is non-electrified, which makes it very simple and low impact to install. We can install in a trench as shallow as 10 inches deep in the roadway. If it's an existing roadway, we saw cut a shallow trench. This system is rapid and inexpensive to build. We use 51R1 rail, which is a low-profile rail, girder rail rolled for us by Voestalpine in Austria, and we lock it into the street, and then add whatever finishes our client wants. Now, in order to reduce and hopefully eliminate the cost of utilities relocation, we keep the low impact cast in place sections very shallow, and then where we need to cross or need to run parallel with city utilities, we can use a low impact panelized track form, which again is only 8 to 10 inches deep. Through the use of these two methods, we attempt to eliminate utilities relocation altogether, which can be a huge cost in the installation of permanent guideway systems. Here we have the TIG-M installed tracks in Doha, Qatar. TIG-M performed everything from curb to curb in this installation, design, build of the entire system. Now, according to our designs, our propulsion system consisting of battery and fuel cell is extremely resilient. This is all designed and built in our factory in California. We have 3 sources of power on each car, thereby virtually eliminating the possibility of power downs on these streetcars. Our hydrogen fuel cell systems, we have formed key partnerships in the hydrogen sector around the world. We can provide on-site hydrogen production. Now, this eliminates the high cost of transportation, distribution, and transfer losses when working with hydrogen. We produce hydrogen locally through the electrolysis of water. We compress it and store it and dispense it once per day in the morning before the streetcars go out for service. It takes about 5 minutes to fuel a car with hydrogen, and depending on the local cost of electricity, hydrogen can be as low as $2 to $4 per gallon of gasoline equivalent. So the way we produce it, it's extremely cheap, extremely safe to use, and provides the auxiliary power on the car that allows the cars to operate up to 20 hours per day without needing to seek off-board power. Here we have the system that we've provided to several countries. Here is the system that we provided for the downtown Dubai trolley system and the first hydrogen fueling station in Dubai. This is the hydrogen electrolysis unit that produces the hydrogen. This is the purification and delivery system. Now, we always mention to our clients the possibility of zero carbon, renewable energy-based self-powered tramway systems. This is our philosophy, this is what we offer, and we've been able to deliver to these systems around the world. We harvest energy through a renewable energy source, whatever the local source is, whether it's solar or wind or geothermal, hydroelectric. We use that energy for our system by selling it at peak hour prices to the local grid and whenever available, sending it directly to our hydrogen generation plant, which operates 24/7, producing and storing green hydrogen. So green hydrogen is stored in the depot. Once per day, it fuels our hydrogen fuel cell. Now, green energy that we have harvested and sold to the grid at peak hour prices, we buy back at off-peak hour prices, thereby creating a cost benefit to our client. At off-peak hours, we use that green energy to charge our advanced battery systems, and through advanced batteries, hydrogen fuel cell, and regenerative braking, these cars can operate 20 hours per day without seeking any off-board power source. So that's our story, and we have produced all of this stuff in Chatsworth, California. We export it around the world. Thank you for your interest in our street and railway systems, and we hope we can be of service to you. So thanks a lot. That's my quick overview of what we do. And any questions or whatever else, let me know.